mean by mutually exclusive event? Bayes theorem and conditional probability. So first we define mutually exclusive event. So we already covered in probability definition. That means two or more events are said to be mutually exclusive if the occurrence of one and the second doesn't occur. That means not occur in second. So two or more events are said to be mutually exclusive one of them occurs occur. So we read events general definition A1, A2, AN are mutually exclusive event if and only if AI intersection AJ is equal to phi empty. That so two events are said to be mutually exclusive if intersection of both are equal to phi. That means, for example, a sample space having 6 elements, that means throwing a die. So 4, 5, and 6. A getting even number, that means odd number 1, 3, 5, or B getting even number 2, 4, 6. So intersection of both is equal to phi. So both are said to be the mutually exclusive events. So, said to be the mutually exclusive events. So intersection of both is equal to phi. Next is independent events. So both second is independent. So for independent events, so that means when we toss two coins simultaneously, so there are two coins tossing simultaneously, that the occurrence of one doesn't depend on the occurrence of second. So such type of events are said to be independent events. So we define as two events E1 and E2 are said to be independent if the occurrence of one does not depend upon occurrence of other. Occurrence of other. So some multiplicative rule for independent event. Multiplication rule for independent event. Probability of event E1 intersection E2 is equal to probability of event E1 intersection, into E2. So this is into probability of event E2. Probability of E1 complement E2. So which equal to probability of E1 into probability of E2 complement. Same as for E1 complements or into E2 complement, you understand that is not in E1. So probability of E1 into probability of E2. And then same for complement of E1 intersection E2. So you write as probability of E1 intersection into probability of complement of E2. So these are some rules, multiplicative rules for independent events. Now we move next definition, which is conditional probability. For conditional probability, that means under some condition is given for calculating the probability. So A and B be two events of a sample space S, and let probability of event B is not equal to 0. So then the conditional probability of the event A given B, मतलब under condition given B, probability of A is different. Probability of A intersection B upon B, A B upon B. So so we can write number of intersection upon number of sample space upon number of B. Okay. 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 So we calculated the probability of A conditional B. So that means probability of intersection B upon PB. So when we calculate probability of intersection B is N, number of element in intersection B upon NS, and NB upon NS. For when we calculate probability of A intersection B, so then we use the formula, this one we write as A conditional B into PB. sometimes we use in this form, same this formula. So we write as probability of A intersection B is probability of A conditional B into PV. And a number of elements in sample space as number of elements in event A intersection B. So we have one theorem related to this conditional probability. So the theorem is if the events A and B defined on a sample space S of a random experiment are independent so then probability of A conditional B is equal to PA and probability of B conditional A is equal to P. So understand this, that means random experiments are independent So that means occurrence of one is doesn't depend on the occurrence of other. So independence, so we already discussed the properties of independent event. So we can write as A and B are independent event. A and B are independent events. So P, A and B, or we can write as P A intersection B, which is equal to PA into PV. This is for both independents. Both events are independent. We already discussed this case. That means multiplication rule of independent event. So we can write as PA intersection B is equal to PA into PB. Now, when we obtain conditional probability, that means PA conditional B, this one. So we can write as probability of A intersection B upon PB. So it means that probability of A intersection B we can write as PA into PB because A and B are independent events are upon PB. So this means that probability of A conditional B is equal to PA. So PB to PB cancel. So PA conditional B is equal to PB. Similarly, you can solve for PB conditional A. So similarly, we can write for P B conditional A which equal to P A intersection B or B intersection A, both are same thing. That means you can write A intersection B or you can write as B intersection A. So this is you can write as PA into PB. So PA into PB upon PA. So PA to PA cancelled. So you can write as P B conditional A is equal to PB. So B conditional A is equal to PB. Okay. So this is related to conditional probability. Now we move to the next statement, that is statement of Bayes theorem. So Bayes theorem is the extension of conditional probability. Here we use the conditional probability for two events. For Bayes theorem, we can apply for n events. All events are mutually exclusive events. So now we write a statement of Bayes theorem. That means if B1, B2, Bn are mutually exclusive event with a probability of Bi, that means probability of each event which is not equal to 0. So here we can use I equal to 1 to n. So of a random experiment, then for any arbitrary event A of the sample space arbitrary event of a sample space of the above experiment with the probability of A, that means this event greater than 0, probability of event A so is greater than 0. We have probability of Bi conditional A. So the arbitrary event shows the conditional probability. That means condition is given. So Bi conditional A is equal to probability of Bi, probability of A conditional Bi upon summation of I equal to 1 to n probability of Bi into probability of A conditional Bi. A conditional Bi. So this is the Bayes theorem statement. So we take one problem related to that statement. We have some mutually exclusive events and probability of each. First we calculate the probability of each event. Then consider the event A. We calculate the okay. So we take one problem related to this. An insurance company insured 4,000 scooter driver, 4,000 scooter drivers, 5,000 car drivers, and 6,000 truck drivers. 6,000 truck drivers. So the probability, that means the event A, the probability of their of their accident are zero point 0.2, zero point 0.3 and 0.5 respectively. 0.2, 0.3, 0.5 respectively. So one of the insured person meets with an accident, one of the insured person meets with an accident, so what is the probability? What is the probability that he is a scooter driver? He is a scooter driver. He is a scooter driver. So understand the question. That means insurance company insured 4,000 scooter drivers, 5,000 car drivers, and 6,000 truck drivers. So probability of their accident is given as 0.2, 0.3, and 0.5 respectively. One of the insured person meets with an accident. So what is the probability that he is a scooter driver? So as the statement B1, B2, Bn are mutually exclusive events. That means we have three events. All are mutually exclusive. That is B1 considered as scooter driver, B2 considered as car driver, and B3 considered as truck driver. So that means occurrence of first doesn't depend on the occurrence of second. That means intersection of all drivers. Scooter drivers are different, and car drivers are also different, and truck drivers also. So we consider B1, B2, and B3. That means B1, B2, and B3 are scooter driver, car driver, and truck driver. So let B1, you can assume B A, that means X, Y, Z, etc. So B1, B2, B3 be the scooter driver, car driver, and truck driver respectively. So the probability of each is, so what is the probability of B1? What is the probability of B1? Can anyone? What is the probability of B1? How to calculate the probability of B1? Yeah, very good, Ishika. 4 by 15. So we make a sample space. So sample space, that means we write NS. So NS having 4,000 plus 5,000 and plus 6,000. So number of drivers are 15,000. So number of, yeah, 15,000. Now we calculate the probability of B1. So that means we take NB1 upon NS. NB1 upon NS. NB1, so 4,000 upon 15,000. So this will be 4 upon 15. And we calculate a probability of B2. B2 is 5,000. So 5,000 upon NB2 upon NS, 15,000. 5,000 upon 15,000. This is equal to 1 by 3. So this is equal to 1 by 3. And probability of B3 is 6,000 upon 15,000. So which equal to 6 upon 15, or you can write it 2 upon 5. So probability is probability of B1, B2, and B3. Now we consider a event. Let A be the event. A be the event of accident occurs. Event of accident occurs. So then the probability of A when accident is occur, that means that is a scooter driver given condition for V1, so which equal to 0.02, and the probability of A conditional V2, that means car driver, this will be 0.3, and probability of A conditional V3, so this will be 0.5. So these probabilities are given, that means the probability of accidents are zero point 0.2, zero point 0.3 and zero point 0.5. Now we calculate the required probability. So required probability, that means it is a scooter driver. It is a scooter driver. So how to calculate this? It is a scooter driver. So that means probability of it is a scooter driver, probability of V1 into probability of A conditional V1 upon summation of Pi, that means probability of Vi and probability of A conditional Vi. So this equal to probability of V1 into probability of A conditional V1 upon probability of V1 into probability of A conditional V1 plus probability of V2 into probability of A conditional V2 plus probability of V3 into probability of A conditional V3. So A conditional V3. So we can write probability of B1. Probability of B1 we already find 4.15 into probability of A conditional V1, which is given 0.2 upon putting the values. So first 4 by 15 into zero point 0.2 plus probability of B2 we 1 by 3, 1 by 3 into, you write into zero point 0.3 plus, next is 5 by 6 by 15, 6 by 15 into zero point 0.5, 6 by 15 into zero point 0.5. So calculate this, and what is the answer? Okay, 0.151, very good. So this is 0.151. And similarly, question can be asked, it is a scooter driver. Second question can be asked that it is a car driver or it is a truck driver. That means car driver or a truck driver. So similarly, you can calculate for both. Okay. Similarly, you can do for car driver or truck driver. Okay. So I am giving you one question. Try to solve this, and what is the correct answer. So note down the question before leaving the session. A bag contains 8 black, 9 white, and 10 red ball. in successive at random, find the probability that both balls are black. First is white and second is black. Note down the option for first question. And options for second. So try to solve this. Okay, so thank you.